So this will be our first topic, statics. So in statics, we have some few objectives that we are supposed to, or rather what we are supposed to cover at the end of this topic. So the first objective is to understand these two terms, that is coplanar and concurrent. So at the end of this topic, we should be able to define those two terms. Then the second objective is to determine the resultant of two coplanar forces using these two methods, triangle of forces method, and then we have parallelogram of forces method. Then thirdly, we are going to calculate resultant of two forces using two methods, the sine and cosine rule. Then we have resolution of forces. And then the fourth objective is to determine the resultant of coplanar forces using polygon of forces method and calculation by resolution of forces. So the fifth objective will be to determine unknown forces when three or more coplanar forces are in equilibrium. So before we delve into statics, we need to look at the broader picture, engineering mechanics. So engineering mechanics is divided into two branches, that is dynamics and statics. Now, in dynamics, we study the action of forces on bodies in motion, while in statics, we study the action of forces on bodies at rest. So dynamics is further divided into kinematics and kinetics. So kinematics is a branch of dynamics that does not consider mass and force, while kinetics is a branch of engineering dynamics that considers mass and force of a body, which is of a body. Now you realize that most of the times we will be mentioning this term force. So we need to define what a force is. So a force is just an external agency that either pushes or pulls, and this action of pushing and pulling may tend to change the state of rest of or uniform motion of a body. So for example, if we have a body which is stationary, for example, if this is a body, then a force is that which causes displacement of this body. So it is either a push or a pull that causes change in the position of that body. So the next scenario where we have a body moving in uniform motion, but a force may come in and change the direction of motion. So that is the effect of force in bodies that are either stationary or in motion. So force is measured in newtons. Now 1 newton is given by 1 kilogram meters per square seconds. Now how does that come in? Remember this equation, force is equal to mass times acceleration. So okay, let's define what is 1 newton. So 1 newton is a force that will cause a body of 1 kilograms of mass 1 kilogram to produce an acceleration of 1 meters per square second. So that is why we relate it to that. Now let's look at what is a force system. So or rather system of forces. When you have a group of coplanar forces, that is forces that act in one particular plane, then we refer to them as system of forces. Just a grouping of coplanar forces is what we call system of forces. Now, under coplanar forces, we have coplanar, collinear, coplanar, concurrent, coplanar, parallel. Then we have coplanar, non-concurrent, non-parallel. So these three diagrams will represent whatever we are talking about here. Now, these three types of coplanar forces. So when you look at collinear forces, let's look at this diagram. So we have these three forces. They are acting on a particular plane. So take this whiteboard as a plane. So these are the three forces. That is force 1, force 2, and force 3, and they are they act in a plane, but in a given line. Then when you look at this, we have coplanar concurrent forces. This illustrates coplanar concurrent forces. So we have a plane, then we have these three forces, F1, F2, and F3, but they are concurring. That is, they meet at a point. Then we have coplanar parallel forces. So these are forces that are acting parallel to each other. Let's take F1 and F2. So F1 and F2 are acting parallel to each other, but still they're acting on the same plane. So this is just, when you look at coplanar non-concurrent, so these are forces that do not meet anywhere. So if we have, they do not meet anywhere. So if I have a body, then this is a plane. So we have non-concurrent, so they do not meet anywhere, and again they are non-parallel. So we have, so these forces do not meet anywhere, and they are also not parallel. Let's look at resultant of a force. How can we get resultant of a force? But first and foremost, let us define what is resultant of a force. So resultant of a force, or rather resultant force, is that force that can replace two or more forces and produce the same effect. So for example, before we go to an example, we have some difference here to note in terms of representation of these forces. So the effect of these forces is represented by a vector. Now, to differentiate between a force and a vector will have two arrows at the end, but a force will only have one arrow at the end. So let's look at an example just to demonstrate. So now we can get at the resultant of a force acting at point P. So we have two forces, F1 and F2. One is F1 is 20 newtons, and F2 is 25 newtons. Now they are acting in the same direction. So this will be the resultant force. The resultant of a force is represented by Fr. So in this case, we have the magnitude to be 45 newtons because we are adding 20 plus 25. So this is gotten by adding 20 plus 25 newtons. Then where we have a case, we can have a case whereby these two forces are acting in opposite directions. So in that case, we subtract the magnitudes of these two forces, and the direction of the resultant force, Fr, will be in the direction of the force with a higher magnitude. So in this case, it is F2, and it is in that direction. So this is how we represent, or rather get, the resultant of a force. Now, when we were introducing this topic, that is statics, we said that the resultant of a force can be gotten or calculated using two methods. So the first method was parallelogram method, and this method, I'll call it construction method. Now, we have this example here. So we have these two forces that are acting from point P. So F1 is 40 newtons as a magnitude of 40 newtons, and F2 as a magnitude of 50 newtons. And the angle that is subtended in between these two forces is 60 degrees. Now, when we want to get the resultant force for these two forces, we need to do construction. So we have to choose a scale. So let's say, for example, in this case, I may choose to use a scale of 1 centimeter represents 10 newtons. So using my protractor and ruler, so you draw a straight line and mark point P. So being that we say that this is 50 newtons and we use this scale, so I will mark 5 centimeters. So this will be 5 centimeters using my protractor, sorry, my marker. Then this is an angle of 60 degrees. So once you construct an angle of 60 degrees, then you do some mark, and then using the same scale draw this force, or a line that represents this force. So that will be 4 centimeter at that point. So we have constructed these two lines, but we are looking at a method known as parallelogram. So what is a parallelogram? A parallelogram is a figure, a four-sided figure, whereby opposite sides are parallel. So this side is parallel to this and this side is parallel to this. So that is what we are trying to come up with, and then look at how we can get this resultant force, that is Fr, for these two forces. Now back to this construction point. So you have to construct a line parallel to this at this point. So let's name this C. So at C you construct a line parallel to A. So let's name this A, P, then P, C. So you have to construct a line that is parallel to P, A at this point. So when you do that, you come up with this line C, B, or B, C. So B, C, P, AP is parallel to B, C, and also P, CP is parallel to A, B. So once you do that, you join these 2 points, AB and BC. So line PB represents the resultant force. So how do we get the value, or rather the magnitude and direction? So magnitude, using your divider, you put one end at this point and one end at that point. So you measure that and then go to your ruler, and then using this scale you convert it back to force. So with that you'll be able to get the magnitude of the resultant force. And how do you get the direction? So you use your protractor to measure this angle alpha. So that is how we get the resultant of two forces using the parallelogram method.